This is for inverse functions, question number 1. So we have this truncus, and the truncus will have asymptotes at x equals -2 because of the +2 here, and 3. And it's a positive, so it's going to look like this and look like this. So this is a many to one function. It passes the vertical line test, so it's a function, but it fails the horizontal line test. Therefore, each x doesn't have a unique y. Each y doesn't have a unique x. So explain why the inverse function is not, why the inverse of f of x is not a function. Because f of x is many to one, its inverse will be 1 to many, and thus not a function. Each x will not have a unique y value. Okay. Now consider function g, where there's the domain D, but I don't know what it is, maps to real numbers, where the rule of g of x is the same as the rule of f of x. Notice the way the question is now changing. We're now going to talk about g, and we're going to talk about the inverse of g, but g is the same as f of x, but for a restricted domain. So to make this 1 to 1, then d is either this side, and I could say that d equals minus infinity all the way up to and not including -2, or I could say that d equals -2 to infinity. Either of them is acceptable. Either of them is acceptable. For this example, I'm going to choose this one as being my answer for part B. So state the interval for the interval D that you chose in the previous question. So the inverse. X equals 1 on top of y plus 2 squared plus 3, which means x minus 3 equals 1 on top of y plus 2 all squared. Y plus 2 all squared equals 1 on top of x minus 3. Y plus 2 equals plus or minus 1 on the square root of x minus 3, which means that y equals -2 plus or minus 1 on the square root of x minus 3. And since I have chosen that as being my rule for the, so I've chosen that. So my domain of f is -2 to infinity, and my range of f is 3 to infinity. Therefore, my range of the inverse will be -2 to infinity. Therefore, I want the positive square root. So g inverse of x is going to equal -2 plus 1 on the square root of x minus 3. The domain of the inverse will be the range of the original, 3 to infinity, and the range of the inverse will be the domain of the original, which is -2 to infinity. And then I need to sketch everything. Okay, so I'm getting rid of that. And this is going to be, now I'm drawing badly with a template, a tablet. So that is my g of x. So we're going to have asymptotes at x equals minus 2 and y equals 3. And I know that point there will be f of 0. And it's going to be 1/4 plus 3, which is 13 on 4. And to find the intersection point 1 on top of x plus 2 squared plus 3 equals x. And that's going to be 1 equals x minus 3 times x plus 2 cubed. That's going to be a pretty awful cubic. And in exam 1, they wouldn't expect you to solve that. So I'm going to use the calculator to give me that answer. So now where I'm looking for my inverse, I'm going to have x equals 3 is going to be the vertical asymptote, and y equals negative 2. And I know that this coordinate will go to 13 on 4 and 0. And my curve is going to look like not curling up. That's the inverse of x. And the intersection point, so if I bring up my calculator, I have x equals 1 on top of x plus 2 plus 3. And I wish to solve that for y. And this one is positive 1 minus the square root. And this will give me negative 1 minus the square root. So if I take that and simplify it, that's my negative 2 plus, and that's the one that I want. That's good. So if I'm graphing, this is the graph of this blue curve. And if I go back up to my original and make that an x, it's the graph of, and if I'm looking for an intersection point, there it is, 0.304. 3.04 is the intersection point. So that's part number 1.